All right, so we're talking about, whoops, where's okay, I do have my microphone. Sorry about that. Um, so we're talking about using some of the theorems about continuity to prove that things are continuous. So let's do some examples. Um, so is the sine of 1 minus x over 1 plus x continuous? And if so, where? So the way to answer that is that we know that all rational functions are continuous. So 1, all rational functions are continuous on their domains. And so in this case, it would be, we would make sure that our x is not equal to minus 1. And number 2, notice that this is of the form sine of some function of x or g of f of x. What I'm getting at is that this expression right here is a composition. And so we also know the sine of x is continuous. So the sine of x is continuous. The 1 minus x over 1 plus x is continuous everywhere except x equals minus 1. So therefore, the composition of continuous functions is continuous. And so this function is continuous at all x except x equals minus 1. Good. All right. And so similarly, how would you do something like natural log of 1 plus cosine of x? Where is this function going to be continuous? Well, let's see. 1 plus cosine of x is continuous on all x for all x. What about the natural log of x? Natural log of x is continuous for x greater than 0, right? So here I do have to be a little bit careful. This is going to be continuous then overall where 1 plus cosine of x is greater than 0. Okay. And so where is that going to be true? That means the cosine of x, yes. Cosine of x has to be greater than minus 1. And is cosine of x greater than minus 1? Yes. It's never more negative than negative 1, right? And so therefore, this is going to be continuous where, this is continuous for all x. Good. Because again, 1 plus cosine, wait a minute. Is that true? I have to be a little bit careful. Because sometimes the cosine of x is equal to minus 1, right? And I'm going to run into trouble there. So I do have to be careful about equals minus 1. Disk not continuous where cosine of x is equal to minus 1 because that would be the natural log of 0, right? Which is not defined. And where's the cosine equal to minus 1? Do you remember? Think about the unit circle maybe. Let's see, the cosine of x is the x-axis. So the x-axis is minus 1 at, hang on one sec. Okay, so the cosine of x is equal to minus 1 here. And so that's going to be x equals plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, etc. Okay, so those are the odd multiples of pi. And so this function then overall is going to be continuous everywhere except for these points, because again, that would make this function 0. And at every other point, the cosine of x is greater than -1, right? So that this thing that we're putting into the natural log would be a positive number. Good. All right. Are you ready to try another one? I think we've got the time for one more here. So how about this one? F of x equals x squared minus 4 divided by, this is exercise number 46, by the way, if you want to read along, divided by x minus 2. If x is less than 2, ax squared plus bx plus c. If x is between 2 and 3, and then 2x minus a plus b if x is greater than or equal to 3. Okay, so we want to find a, b, so that f is continuous everywhere. Find a and b so that f is continuous at all x. Good. All right. Now, just visually, we can see what's going on here. Just to kind of keep us straight, somehow there's a break in our definition at 2 and at 3. On this side, we have x squared minus 4 divided by x minus 2. Here we have the parabola ax squared plus bx plus c. And then here we have 2x, maybe I'll draw it down here, 2x minus a plus b. Okay. Let's see, how am I going to solve this? Well, for one thing, I think I need a 3 here to make it equal to number 46. Okay. Now, how do I solve this? I was getting carried away there. Well, the points that we have to be concerned about are points x equals 2 and x equals 3. So we just go right through the definition. So let's take a look at the point x equals 2. Does the limit as x approaches 2 of f of x exist? Well, the limit, it depends on which direction you use, right? Because if we go from the left, we're going to be using x squared minus 4 over x minus 2, which is, did you see the cancellation there? That's going to be x minus 2 times x plus 2 divided by x minus 2. And so coming in from the left, we're going to end up at 4. What happens when we come in from the right? Then we have to use this parabola, right? Ax squared plus bx plus 3. And because this is a parabola, the limit will be what it is if we just stick the number in for x, right? And so that limit is going to be 4a plus 2b plus 3. Good. So far, the limit exists. Do you see what we're going to do? We're going to equate these two things. If 4a plus 2b plus 3 is equal to 4. Okay? And if that's true, again, the limit exists. Finally, what does the limit have to be equal to? So the limit has to be equal to, let me get some new paper here. The limit is equal to f of 2, and we see that f of 2, if you look at the formula, you're going to use this formula. F of 2 is going to be the 4a plus 2b plus 3. Okay? So far, we haven't said anything new. So continuous at x equals 2, if, notice by the way that what we're really doing is just coming in from this side, and we're making the values equal to each other, right? So on the one side, coming in from one side we had 4, and on the other side we had this, 4a plus 2b plus 3. So we need to make those equal. 4a plus 2b plus 3 equals 4. So how many is that uniquely defined? And in fact, let me just say 1. This has an infinite number of solutions, right? And so we have to go to the next issue, and that is at x equals 3. And now we do the same thing at 3. Does the limit as x approaches 3 from, does the limit overall exist? And so in order to answer that, we have to break up our limit into 2 pieces. So we have to break up the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. Okay, I'm writing kind of crooked there. If we're coming in from the left, that means we're using this formula. Notice that if you were to go too far left, you would be over here, right? But that would be too far. We're just interested in what happens close by 3. So that's why we're going to always use this formula, the ax squared plus bx plus c in this case. So if we're coming in from 3 from the left, that's going to be 9a plus 3b plus 3, right? And then what happens as we come in from the right? From the right, we're going to be using the other formula. So that's going to be 2 times 3 is 6. Oops. I should have put something else in there. Oh well, you get the idea. The limit as x approaches 3 from the left is this. The limit as x approaches 3 from the right of, this is what I meant to say, minus a plus b is equal to, and then plug it in. 2 times 3 is 6 minus a plus b. Okay, so when does the limit exist overall? The limit exists overall when these two are equal. So therefore 9a plus 3b plus 3 is equal to 6 minus a plus b. Okay, so simplifying that, looks like we get 10a plus 2b is equal to 3. Okay, and then what is f of 3? Just to double check, the formula says that f of 3 is going to be using this formula again, so we're going to get the same thing, 6 minus a plus b. Okay, and so if these two things are equal, then it'll automatically be continuous. Okay, so now we have two conditions. We have 4a plus 2b equals 1, and we have 10a plus 2b is equal to 3. Good. Do you remember how to solve these? Well, one way to solve these is to do elimination. And another way to solve these, oh boy, we're running out of time. Let's see if I can finish this quick as a bunny. I'm going to subtract the first equation from the second to get rid of the b's. And so that would be 6a is equal to 3 minus 1 is 2. So therefore a is 2/6 or 1/3. Okay, and then from that you can say that 2b is equal to 1 minus 4a. So we divide by 2. And so that would be 1 minus 4/3, 4 times 4/3, 4 times 1/3. Sorry. I'm trying to finish this up real quick. Okay, you could finish up that arithmetic. All right, so now we found a value for a and b for which the function was continuous. Okay, and again, just to give you a quick update there, if you were just to come in from this side and check that it's the same as coming in from this side, then you're good. Same thing for these two. And that's kind of a shorthand for what we just did. Okay, I'm running out of time, so maybe I'll do one more example after that.